Cool. All right, we're rolling. But yeah, so I was just saying, welcome to the cadCAD community call. This is the Oceania time zone friendly call every other month. We do one in the morning European time, so it's cool though. We usually don't have a big audience. I personally don't really know many people from that part of the world working on cadCAD things, but this time I actually really tried to reach out and ended up digging up a few. So this is great. I'm really glad you guys could all make it. And yeah, so the plan basically today is just to have really a casual conversation, I think, in the end. It should be kind of fun just to get to know each other, meet each other, see what we're all working on. I think a few of you have actually kind of planned to present or show off the modeling or work you've been doing. So we can kind of use that as a rough template, but otherwise, just excited to get updates from everyone and see what we're all working on, share some ideas. But we could maybe start with a quick round of intros. So let's do that. We'll just go with name and kind of what your background in token engineering is, how you got interested in cadCAD, and then without giving too much detail away, maybe mention what you're working on, if you are working on anything that you're going to talk about today. So I guess I can start. So my name's Peter, and I got first got involved in the token engineering space actually almost a year ago through the TE Academy, and have been slowly spending more and more of my time in various communities like the TEC, cadCAD, TE Academy, Block.Science, Common Stack, and have been officially full-time in token engineering since this past summer. And at the moment, I'm working with TE Academy, so working with Angela, and we actually just got a new team member named Patty. And so the three of us are working on running all the TE Academy programs. And I was leading the OmniPool research program. If any of you saw notes about that coming out, we just wrapped that up last week. And then I'll be also helping out with the reward systems research program, which is starting just in a couple of weeks. So that's been my focus recently, but I also do these cadCAD calls on the side. And yeah, really just discovered cadCAD through token engineering space and haven't actually been able to spend too much time using it just because I've been busy with other things, but I really do see a lot of value in it and would love to personally get some more practice using cadCAD, and would love to work with it a lot more. So that's kind of my motivation for sticking around the community. So I'm excited to see what you guys all have for us. And maybe I'll pass it to Indexed if you want to go next.
Yeah, hey guys. My name's Joe. I'm a software dev. I first heard of cadCAD a while back. I can't remember how exactly. I think it was through Block.Science. I was just surfing the interwebs and looking for various Python libraries that would help with simulating some things. But I got involved more closely with TE Academy. Did their first course and then participated in one of the research programs in the balance of simulations. So did a simulation on, I think it was using dynamic AMM, so changing the weights variable, and I was running our simulations through cadCAD, through cadCAD. Since then, that was earlier in the year. I haven't really touched it too much, but I'm keen to. I found a lot of value in using cadCAD, and continuously would like to use it for other areas of interest in the future. So yeah, that's a bit about me. Pass it on.
Awesome. Maybe
On to qwerte.
Hi, I'm Jono. I believe I was introduced to cadCAD through Indexed. he sent it my way, and I found it pretty interesting. We tried I tried the intro course, and then sort of touch it until the Gitcoin research program. I worked with the math group. We again didn't end up touching that, and then forgot about it for a while until I was poking around this economics professor, totally unrelated, but he had developed this software that does sort of, dynamic system modeling, differential equation stuff, and he spoke very highly of in this YouTube interview that I was watching, and it occurred to me that it was essentially cadCAD, and so that piqued my interest. In particular, I was kind of just the idea had been floating in my head for a while, to attempt to do a sort of simple simulation of a sort of different paradigm for macroeconomics based on work of Richard Werner, if any of you have heard of him. So I figured that I would run a slightly simpler problem, and I have implemented it in a solving heat diffusion in a metal rod in a very realistic case scenario. So that's also what I'm going to be showing today. Outside of doing this stuff, I mostly do sort of data science-y, data analysis related things. So yeah, that's me.
Awesome. Really cool. So non-blockchain application, non-crypto application. It's cool. Trang, you want to jump in?
Sure. Hey, everyone. Hi, Peter.
Hey.
Hi, Joseph. I'm Trang from Vietnam. My background is actually in material science. I did a lot of simulation back then, but it's totally different kind of simulation. It's more about physics and mechanical. I just recently jumped into token engineering and crypto space. I think it's about up to June and July when I joined Token Engineering Academy research group, balancer simulation, where I met Index. And since then I studied a little bit about cadCAD already, and I had a chance to dig into a model named GEB-simulation, which is a cadCAD model of stablecoin named RIDE. I'm gonna talk a little bit more about it later. But yeah, besides that, I am also developing and contributing to develop Token Spy, which is a agent-based simulation with EVM, which initially developed by Trend, the founder of Ocean Protocol. Yeah, I think that's pretty much about me.
Cool. Thanks for the intro, Trang. And last but not least, witwiki.
Hey guys, my name is Vikram. I've been, I guess it's been almost a year now since I've sort of gone spent most of my time in crypto. So I came across cadCAD about a year ago now, and mostly using it. Been using it Sorry, I've been doing the I think the hack sessions, which are kind of interesting because they're kind of interesting tidbits that help. Apart from that, I don't really use cadCAD. Most of my sort of I do mostly freelance at the moment to pay the bills, and that's mostly research and writing. Prior to that, I come from like the aerospace background, so I did mostly operations and mission management, and before that, I started out as a satellite data engineer. So was in that sort of previous life about 6 years doing that. Um, my interest has always been trying to blend two ecosystems or sectors like crypto and space. Since I heard about smart contracts back in 2015, 2016, I've been trying to figure out how I could do something like that. So I'll be showing some of the work that I've been trying to do, but it's still not. I mean, it's not very technical. It's pretty high level still. Still started out doing the math spec, and yeah, I'm gonna try out cadCAD for the sim. So for the model and sim. So yeah, that's me.
Awesome. Very. Oh, there we go. I was muted. Sweet. Thanks for the intro. A lot of diverse backgrounds, so that's really cool. Yeah, should make for some good conversation. So, does anybody want to go first, showing off their work, what they're working on, or I'll call someone out.
Happy to
Sure.
start.
All right, trying unmuted first.
Okay, I got the prize.
Yep, you win.
Yeah, maybe I will share my screen. It's like I briefly talk about. It's a so I prepared a couple of rules on the cadCAD model that I am on. It's like I said, it's a cadCAD model stablecoin named RAI, which is not pegged to anything, not pegged to dollar, which is quite innovative. And I mean I had a chance to work with it, and huge model, which a lot of things I don't understand yet, but it's for casual chatting. Its name is GEB-simulation. I forgot how they call it GEB, but basically it's a thing developed by Reflexer. It's allow anyone to leverage assets and issue stablecoin. First one is RAI, which collateral is, but I mean it can be adapted to any other crypto asset. And the code is actually, I mean, the smart contract code is actually kind of initially quite, they call it purple paper of MakerDAO, which never implement. And I'm not sure how the different, but it's like a upgrade version of DAO, or maybe a different version, where they implement a PID controller to stable secondary market of the stable coin, and use redemption price mechanism as a stabilizer. And the GEB simulation is essentially a cadCAD model which simulates RAI system. Like I said, it's a huge cadCAD model, which I mean the simulation help the reflexer team to integrate the PID controller to the system and select parameter that optimize the system. Like Block.Science has a method to like selecting parameter and certainties. I think this is like the one that they apply this kind of methodology to select a lot of different parameters. So the simulation is in a very high level point of view. It's use a Ethereum price and liquidity demand. Like there are two things that is like environment parameter which we cannot control. One is Ethereum price and the other is how much is the demand of liquidity of the pair RAI and ETH, which in simulation it is a Uniswap pair. So we can't control how much people want to buy RAI and how much what sell it on Uniswap pool, which is a secondary market. And of course Ethereum price can't. And in the cadCAD model, they also have agent which will act when the Ether price changes or when the PID controller set something differently. For example, the one who like deposit Ether and then take some RAI loan. For example, the agent in the simulation, they have simple logic, like if the price go up, and then they have more power to mint more, right? To mint more stable. So he has a say a certain threshold of ratio. So if it go up, then he will mint more RAI and then sell it to the market, and he does otherwise on the opposite direction. So like I said, it's a very, to me it's very complicated model because it's agent and use another smaller cadCAD model to generate Ether price as simulated data set. And each agent implement as a partial data update block. Like what I like to use cadCAD is easily you can manipulate and easily can change what parameter you want to see, what parameter change. Like this is a Ether price where you can easily just pass the price as like 30% shock, and then see how the system react to that kind of shock. 30% in like go up 30% for 6 hours and then go down to 300. So yeah, it's kind of very easy way to see the effect of parameter, and also can do some parameter sweep. Just update and then see how the system react. So this is a like the shock. The example run of the shock of Ether price, where it go up 30% in 6 hours and then go down, and then do some parameter sweep of the controller parameter, say KP and KI. By the way, the controller, what it control is a redemption rate. So by changing the redemption rate, the controller will change. I mean, the redemption price will change. So what the controller does is changing the redemption rate. So as you can see here, I mean, another thing about cadCAD that I like is easily manipulate the results, and then I mean, it's essentially a data frame, pandas data frame, and easily manipulate and use it to visualize. Like here's baseline, ether price doesn't change, it stay 300. The redemption rate doesn't change, it stay 0. But in essentially, okay, baseline run 1, and because the redemption rate doesn't change, the target price doesn't change either. Target price is a result the redemption rate. And the other case is like the impulse of ether price. Like now the PID has a lot of work to do, and you can see the difference of how the controller work in different parameter. Like we have a grid of 4 different KI and 4 different KP, and we see, like visually see the in short, like if we have bigger KP and bigger KI, then the redemption rate will change more aggressively. Like the value the controllers is bigger. And yeah, here by changing the redemption rate, target price change, and then it's essentially trying to stabilize the secondary market price. And you can see here it's a bit clearer, because in this case I set a controller turn off first 7 days, so you can see like the market price that doesn't have any data first, but if you zoom in, then it's you can see it's more clearly. Yeah, so yeah, like this is what I had a chance to dig into, which is, I mean, a lot of other cases for the sake of thing today, and yeah, just
Really cool. So I guess in this chart, so we see the market price doing the 30% increase and the 30% decrease from the shock that was programmed. Is that, oh, that's in this here. Oh no, this is the APY.
like this?
Yeah, so this is the code for the 30% shock, and then in the charts at the very end is where we actually see the change in market price. Or is market price not Ethereum in this case?
Market price is a right price. So
Okay.
it's a stable coin price. Yeah.
Cool. And so do these charts suggest that the controller like successfully controls with the shock to the ETH price and like stabilizes the system, or does it say that it's pretty volatile still?
Actually, I mean, these charts, me, it's more about comparison between different, like visually compare. But inside the simulation, they do implement a thing called KPIs.
Mm-hmm.
Like the KPI is measuring volatile, the market price, and some other thing. Which with that with that we can like compare quantitatively. This is like, to me, it's more about quality, seeing how the different of the redemption rate, different set of parameters.
Yeah. Okay. Cool. Awesome. Anyone else have a question? I got one more actually. So I know you do you work with Token Spice also.
Yeah.
How do you find the differences in the agent structure for cadCAD versus Token Spice? Is there like a major difference in how they're set up? Do you have a preference for doing agent simulations in Token Spice versus cadCAD?
I think the main difference is agent in Token Spice has actual Web3 wallet, so it has address, it's interact with with blockchain, which currently it's a local ganache, like doing transaction. But the agent, for example, in this price system, then it's pure Python. So it's agent, but essentially it's a partial state update block. So like it has one state. Every time step it will get update. As any other, like the same as any other like state. So it's I think it's huge different. Yeah.
Okay. Cool. Awesome. And then, do you know about the Rye workshop? I think you messaged me about this, right? The one that TE Academy is hosting.
Yeah.
Awesome.
That's pretty cool. That like it's a different cadCAD model. Like, it's not this one.
Oh, okay.
Yeah, it's but yeah.
Nice.
I took a look on that.
Yeah, and so
just
for the other
everybody.
guys, the TE Academy is hosting a workshop series with Reflexer Labs and Block.Science to introduce the community to the digital twin, the cadCAD digital twin. And I thought this was the digital twin this whole time. But I guess I'm going to learn something on Thursday too. But yeah, that would be a cool session if you're available.
Do you know if that's recorded? Because it's they're generally like way off like the times that I'm awake. So
yeah,
the work was like
yes, it will be recorded.
Okay, cool.
I will be recording it.
Oh, okay.
Yeah. But yeah, good question. Cool. Sweet. Thanks, Trang.
Yeah.
This was awesome.
Sure.
And well, and I guess kind of curious, why are you digging into this? Just for fun, to try a new cadCAD model, get more experience with agents in cadCAD, or what's the goal?
No, actually, I'm working on a project, like a friendly fork of this RISE system. But of course, it's for another collateral access.
Yeah. Cool.
Yeah, so it will be like another GEB system with another token as asset, which I can't tell that.
Ooh, I kind of am losing connection. You sound like a robot now. For me, at least.
Yeah.
No, not. It's very choppy for me.
I can't hear either.
Yeah. Maybe he's gonna jump back in. But I think.
You mean now?
Yeah, a little better.
Okay.
You were just saying you're working on another project. Yeah.
Yeah, it's
Cool.
basically a fork of GEB system with another collateral access.
Nice.
Yeah, it will be another GEB system.
Sweet. Well, I'm definitely curious. So hope we get
Yeah,
an
stay
update at
tuned.
some point.
Yeah.
Cool. Sweet. Thanks, Trang. Would anybody like
Sure.
to jump in next?
Yeah, I can go.
All right. Floor is yours.
Yeah, just let me know if you can see it.
Not yet.
Now?
Yes.
Cool.
Yep.
So yeah, just a disclaimer, this is pretty high level. I'm still working on the mathematical specification. And it's also my first deep dive into cadCAD modeling. Like most of them generally been I think the hack session stuff, which the cadCAD EU guys do. So yeah, so I'll be showing modeling an auctions market to coordinate and price-based debris risk. So I think you already know a bit about me. So yeah, I did about 6 years before what I'm doing now in space. So yeah, so this is kind of like the problem I'm trying to solve. So currently there are quite a lot of space debris, both active and passive, in Earth's orbital corridors. So most of your GPS satellites are around here. GNSS, Galileo, they all like your global positioning system around here. And then these, if you can see that over here, that's like your low Earth orbit. And that's where a lot of the currently most satellites hover. If you've heard of, I'm sure you've heard of Starlink. And then you have Jeff Bezos' company as well doing the same thing, and they're trying to do satellite internet. So this area is going to be way more crowded in the next 5 years. So that's a huge problem. And if you ever heard of like the plastic pollution issue in the Pacific Ocean, the plastic garbage patches, those it's kind of like that. And these are all objects above 1 millimeter. There are objects smaller than that, which are even worse in your orbit because they travel faster. They tend to travel faster. So these are crowded orbits. So last year in 2020, we had like the largest number of satellites launched since humans ever ventured into space. And then also conjunction assessment. So it's just a domain within the space sector that deals with determining the probability of collision between generally two objects. One is the active one, the other one's passive debris. It can be more as well than two. So yeah, some of the data here is also quite old. I haven't updated these slides in a while, so these are a lot bigger, but these are generally the popular form factors for satellites these days. A nano satellite is about like the size of a poster, and a microsatellite is the size of a bar fridge. And then you have like a lot more launches happening these days. So this is kind of like the closest thing to the latest data. As you can see, 2020 is like the largest, and most of this is just Starlink satellites over here. So that's quite a huge, and that's just going to increase. So, why I use a cryptoeconomics protocol to price risk. The timing, you have primitives like bonding because control theory are more commonplace now. You have Verizon constellation satellites, expecting 100K satellites in 5 years. The other thing, which is indirectly related to what pricing risk, is liquidity in the underwriting of in-orbit space insurance products. So basically, in space insurance, you have two types. One is launch, and the other one's in orbit. In orbit's always pretty illiquid because there's a lot of uncertainty when your satellite's in orbit. So the solution is, what I guess I'm calling right now is the watchtower protocol. It's really kind of similar to how you have the regen protocol and then Flucon protocol, and that are working on regenerative agriculture and then carbon offset stuff. So this is trying to focus on space debris mitigation and management by pricing risk of potential collisions. So essentially, it's a risk pricing protocol. So just a bit of background on what conjunction assessment is. There are generally three phases. You have event screening, you have risk assessment, and mitigation. Um, so um, you have companies and institutions in all these sort of stages of it, and some of them are in both or all three. Um, so at the moment, um, the focus is just on this one, with eventually going to event screening, then eventually mitigation as well. So this is just a general high level ecosystem map of who the players are. Don't spend too much time on that. So you have three markets. So this is the auction market that I am currently working on. So you have two main roles here. You have the guardians, or the essentially data scientists, who help determine probability of collision, the measure that's used to determine probability of collision of two objects. And then you have watchers. These are just ground stations observing the satellites. So one of the other problems which would be tackled in the future is coming up with the decision on what the best data inputs are. Currently, it's just data inputs provided by watchers, and some of these watchers are like, they do PC calculations as well. So they'll provide their sort of PC calculation. And then you have a global crowdsource of data scientists working on PC calculations within the given time frame. And then just really comparing the two, and that final PC is what can be used in insurance companies, etc. So the system has at the moment four states. The zero state is essentially time invariant. It's where your guardians or data scientists sign up. They're educated in the process of calculating probability of collision. So the process is rather straightforward, what I've been reading. And this is where they set up the wallets for the first time, and get all the resources and pretty much everything. And then the initial state is where they're provided with a conjunction event, and that is essentially a screened conjunction event. So before we provide a conjunction event for the scientists to actually determine the probability of collision, we need to screen them to make sure that there's actually a possible conjunction event about to happen. And with that, you'll have a certain time frame by which they have to calculate the probability collision metric. So at this state, all that is really set and is ready. And then once that's ready, once the trigger, the screened event is kind of like a Boolean trigger. So once that's triggered, it goes into the execution state. And in the execution state, that's when like all the agents. So over here, in this case, a data scientist treated as an agent, with their own sort of private beliefs on what their um, their their sort of modeling tells them about the PC score, and they essentially bond. So probably go that in the next few slides, but they bond their stake and then they submit their score. And then there's also going to be a dispute resolution sort of state eventually. But space dispute resolution is like, I think, about 80% of most of space law. So it's a huge rabbit hole in itself, which I'm not a lawyer. So that's something that's going to be there in the future. But for the moment, it'll just be a simple settlement state partnered with whatever watchers tend to partner with us with the watchtower protocol. So yes, so state variables. You have your token supply, claim token bonded. A test whether it's a success or failure of bonded tokens. Then you have reserve. You have price set up, price at timestamp. Yeah, your probability of collision with is the alpha, conservation ratio, and on curvature. Then you have the aging variables, which are similar, some of them similar. So you have the private attestation of PC. So these are your individual agents with their own PC scores and with their own token reserves and tokens that they have supplied. Um, there's really four mechanisms. So it's bond to stake, bond to unstake, and then it tests true and false. So testing here is really the PC score. The PC score has a threshold of 1 in 100,000. So that's what 10 to the negative 5. And essentially, if the probability is greater than 10 to the negative 5, then it is true, which states that there's most likely going to be a collision. So your agent will attest true to that. If the PC is less than 10 to the negative 5, then there's a less likelihood of a collision, so they'll attest to false. And that would affect their sort of change in their stake, the amount that they stake. And then the final attestation would be your private beliefs from each of your agents and just an estimator here, most likely what based on sample size. So still thinking about how to do this, but at the moment it's just going to be like whatever's the most dominant PC scoreboard will be that estimate that will be compared to what the watches provide us at the start. And that's pretty much it. So if you're interested in looking out, yeah, you're welcome to join as well. So yeah, that's pretty much it for me.
Wow, you're literally modeling the universe. Really cool.
Yeah, so it's level.
Are there already a lot of risk assessment agents today? Like, do those exist, and is it in the reinsurance companies, or is
Yeah,
that
so
another
there
area we
are
need to grow?
yeah, so there are like so most companies now they do both the um they both do the observation of the sky, like they detect, they have ground radar or they use RF passive sensors, I think. I can't remember the second one. But yeah, generally some kind of radar to determine the position of the satellite and the passive debris. And they use the ephemeris, so mostly the orbital elements, and use that to um, determine whether. So the way they calculate is like, from what I understand, is like they they draw a sphere around each the active satellite and the passive debris, and the spheres and they determine that spheres based on the position that they have captured from their sensor. And if those spheres kind of like merge, then and how much they merge kind of gives you kind of a sense of how much what the probability of collision is. But yeah, most companies who do the sensing of the position of satellites, they tend to do the PC calculation as well. But what's the issue? The real problem is like the sensing aspect of it, because not everyone sort of agrees with where the position of a satellite is, and that's primarily because the space sector was really born out of weapons manufacturing and military since the Cold War, and as such, like data sharing agreements are never transparent. They're always siloed, and they are generally behind defense or military walls. Um, so, I mean, I don't know. I mean, I'm not sure if you've ever gone to a space conference, but it's always like it's very secretive. I mean, you might as well go to like might as well go to an intelligence conference, so like DEF CON or something. But which I always found kind of odd. But yeah, because of that kind of sort of aura and atmosphere, it's very hard to actually solve problems like this. So the real intention of this is to make it more transparent and yeah, censorship resistant as well. So yeah.
So cool. All right, disrupting the space industry. So cool. That's awesome, man. All right. Then last but not least, was it QWERTY? Yeah, you were gonna share.
Hey, yeah. Okay.
Cool. And I see we have about 10 minutes left, but it's okay with me, at least, if you run a bit over or if we go over with questions and stuff.
Yeah,
so
right. I'll try
no
and keep
rush.
it short.
Cool.
Sure. I'll try to keep it short. It's not very long anyway.
Cool.
So yeah. So my thing was just to sort of experiment, just to play with cadCAD and just sort of get used to it before attempting something more complicated. So this is what I settled on because this is what I know. I studied maths, so this came to me. This sort of just came to me naturally. So I'm just going to go with two main things. So the problem, I assume that the other two speakers, having done a bit of the physics related things, might be familiar with this problem. But essentially, I couldn't find a nice picture, but this is sort of the idea. It's basically you have a metal rod, and it has some initial temperature, and the idea is that when you press play, the hotter bits, the heat from the hotter bits is going to sort of um, smoothly warm up the cooler bits, um, and the cooler bits are naturally going to cool down the warmer bits, and so you get a heat transferring across the metal rod. Uh, for the example that I used a sine wave sort of initial condition. So the way that you can imagine it, and I do have a diagram a bit later, is essentially you have a metal rod, um, and it's got a sort of hotter bit, which is on the left of the center, and a cooler bit right of center. And by the way, this was written with no intention of it ever being read by anybody except myself. So if the language is a bit casual, that's why. Um, so yeah, so the way that I broke it down was just an analytical solution first. So this is the calculus training in me. That's a very simple application of you know, some basic differential equation stuff. So I'll go over that very quickly so we can understand the solution space and what that looks like. And then I do the cadCAD solution, which actually took some mulling over, and it's sort of agent-based, sort of not. Again, that delineation was a bit unclear to me, but I made it as agent-based as I could wrap my head around. And I'm going to finish off with a little bug that I was actually hoping that maybe somebody could, point out if it's obvious or something. Anyways, so I just set up my thingo. I set up the rod. Here's the initial temperature, that sine wave. This here is the temperature across the rod. And what I realized is that I could use Plotly. Uh-oh. Where'd it go? Oh. Wait, is it down here? Uh-oh. There we go. Yeah, so I realized that I could use Plotly to sort of make it all pretty and visual for myself, so I did that. So here is a sort of visual representation of the metal rod. Here is the hotter portion here on the left and the cooler portion on the right. And so, yeah, you would expect that if we were to press play on this situation, you would have the warmer bits sort of moving towards the right and the cooler bits moving towards the left. And that was essentially what I wanted to implement in CAD. So first, the analytical solution. Stuff is, I don't know, differential equations 101. I just Googled around, and, because I couldn't remember it off the top of my head. Plugged in the initial conditions into the right equations, and you get this analytical solution. If you guys want more details, I can point you to the right place, but it's a very common problem, so nothing you couldn't find by yourself. So this first little visualization is just drawing the solution space. So in this diagram, the metal bar is actually oriented this way, and let's see. Yeah, so this here, this purplish color, that's the warmer part of the rod, and this is the cooler part. And you can see across time, the idea is that the metal rod sort of reaches equilibrium. So that's sort of a three-dimensional view where one of those dimensions is time of the model. So continuing with the analytical solution, I just put into Plotly so that I could make it a pretty little animation. So if I click play here, yay, and it reaches equilibrium. So yeah.
That is so cool.
Thank you. It's yeah.
Yeah.
It's a really simple project. So
I mean,
making a little visual.
Sorry to interrupt.
Sorry
to interrupt, but yeah, I agree with
No,
Peter
no.
that this
Go ahead.
is the coolest thing I ever seen using cadCAD. Like, right? I mean, using
this isn't
cadCAD
even the
for
cadCAD
physics
yet. This is the
problem.
Yeah.
Okay. Cool.
We'll get to that in a second, but thank you very much, guys. So basically what this is playing here is it's you can imagine like a thin window here this way, and it's sliding that window across this way. So that's basically what this little quote unquote animation is doing here. So anyway, this is using, again, the analytical solution, which, as you can see, you're putting in an x coordinate and t coordinate. So, it's that's the hacky, sorry, not the hacky, the formal solution, right? The mathematician's way. But of course, I have to put on my engineering hat and attempt it again from a cadCAD sort of perspective. So yeah, I noticed I looked around and saw the radCAD and read around with sort of how to look around at other people's implementations of doing it sort of object oriented, and this was sort of what I could come up with. So essentially, I was using a dictionary of slices of the rod as the agents, and each agent is given a temperature, and the behavior is to update according to the neighboring agents, naturally. Um, this isn't perfect, but this was my solution. Okay, so yeah, so this is sort of what I started with, right? The temperature of any agent is going to be the previous temperature plus a change in temperature over time, and uh, the this is from the heat equation stuff, which again, it's quite easy to search up. And then you can sort of induction it by using the fact that we have an initial temperature at t equals 0, right? So you can put in t as O, and you can get u of t1, and then you can put that one in here, and then get u of t2, put u of t2 here, and et cetera, et cetera. And that allows us to sort of recreate the animation, but from an object-oriented sort of vibe. Let's see. Yeah, so that was just doing some algebra to make sure I actually had the numbers. Yeah, so this was just my speculation. I don't know, maybe if you guys can think of a more object-oriented way to do this. But I think the problem is that you have to get into the heat energy stuff, and that was just a level too deep for me at the time anyway. So I went with a simpler solution of just sort of subbing U back into itself and being able to pull out a nice simple equation. And then I shove that into cadCAD, the cadCAD, what do you call this, template. There's all my bits and pieces, my state update, and then I shove that through the simulation engine, repeated the animation, and I got this, which, if I play, is half correct. I'm not exactly sure what's going on here. So if I just replay that, at the first time step, this cold bit just disappears, goes to 0, right? So this is the time step after 0, and this is the case for all of the time steps after 0. And I actually don't know what's going on there. Obviously, with the hotter portion, it's playing correctly. It's cooling down the way you would expect, but this colder portion is not. I did some poking around, and it seems to be further under the hood than I could allocate time to investigate. So I don't know if you guys have any idea what the hell's going on here, then I'd love to hear it. But otherwise, that's my implementation. This was my little cadCAD project.
Can I ask, like, why are you doing it? Are you like learning cadCAD and then just
Right.
see? Okay.
To be honest, this was sort of a practice thing. I want to implement a cadCAD model for a sort of different macroeconomic paradigm based on some of the work of this professor whose name is Richard Werner. He had some theories as to what the hell was going on in post-war Japan until today. And essentially his whole argument, which is not unique to him, is that, the reason why so much of the Japanese economies, like, quote unquote, missed, the fact that raising rates did nothing, and et cetera, et cetera, was actually to do with monetary metrics, like quantity related metrics. And he provides some nice sort of cadCAD-esque flow models, right? And it just occurred to me, like, oh, I should try to build this in cadCAD. But then I realized that I was not fluent enough to be able to implement it. So this was sort of a stepping stone of, a really simple, actually wrap my head around what these P's and S's are, and how to actually structure a state update, and all that. So long story short, the motivation behind this was to wrap my head around cadCAD, radCAD as well, right? New thing that I hadn't heard of until I poked around to try this.
What is RedCat?
No idea,
It's like,
but it's like a wrap around cadCAD. I basically just copy pasted a method.
I'm not sure
Trying
the
my best to understand sort
mechanism.
of big picture of what they do.
I think it's meant to be a Rust-based implementation of cadCAD. It's meant to be a bit more like efficient, because it's based out of Rust, so which is not a scripting language. So you're it's kind of like similar to using a lower level language like C or C++. I think that's what RedCat is. It's meant to be more.
Yeah, that was more or less my understanding. It's just a sort of smoother, streamlined implementation or something.
Yeah, for like larger models, to make it more efficient.
Yeah. Probably solves a lot of the issues that Python has.
I think, yeah.
That's cool. But yeah, nice presentation.
Thank you.
And
just out of my curiosity, like why are you choosing a heat transfer problem for learning cadCAD? Just my curiosity, because I did a lot of simulation in a manufacturing called heat treatment, and it's used a lot of in mechanical simulation world. We have a method called FEM. Maybe you know about it. Like break down the big the big physical thing into smaller pieces by mapping it in like point by point and smaller element. Like I had a.
You're asking. Sorry, continue.
Yeah, I mean, what I'm asking is my curiosity, because I work with heat transfer stuff quite some time. I'm just curious why you like learning cadCAD by this problem.
Yeah. I figured that you would be familiar with this stuff. So I was expecting this question from you.
And
I
guys,
actually
sorry to interrupt. I actually do have to run though to another call. So I'm gonna wrap up, but you guys are more than welcome to keep talking.
Sorry.
Yeah, can you hear me? Oh, maybe not. Sorry, can you hear me? Maybe now.
Yes.
Okay, cool. Sorry to interrupt. I just have to go run to another call. So I'm gonna wrap up and say goodbye, but you guys are more than welcome to continue the conversation, last few questions. And I'll just say thanks a ton